Okay, this is the review for the test that we're going to be having, so make sure you pay attention to what's going on. Remember the difference between a population and a sample. When we did the gym floor, we were doing a sample of the gym floor, okay? A sample is when you just take part of it, and so of the whole gym floor, we only measured, what was it, 27% or 23%? I don't remember what exactly it was. But tell if this is a population or a sample. The police determined that 20% of the drivers on St. Patrick's Day were OWI. That's operating while intoxicated. Now, the only way you could tell if it was 20% of all the drivers is if they stopped every driver. Well, they didn't stop every single driver, so they just did a sample of the drivers. Next one. Okay, this is one of those scatter plots. We're used to scatter plots, right? We know what we're doing. Let's look at this one. For the following scatter plot, what happens to the body temperature as the heart rate increases? Notice body temperature is the independent axis. Heart rate is the dependent axis. So they're saying that whatever body temperature you are determines what your heart rate is. If you notice, these dots aren't very close to the line, and that's indicated by this r squared. Remember, if r squared is close to 1 or negative 1, then it is, then we would say that those two are very closely related, but these two don't have a very close relationship. As the body temperature goes up, the temperature goes up. Now, I would also accept no strong relationship because of this 0.06. But given the fact that the line is there, that might be somewhat deceptive. Remember that the line indicates y is the heart rate, so we would say the heart rate is 2.44 times the temperature minus 166. So if you have a temperature of 100 times 2.44 is 244 minus 166. Let's see, what is that? 244 minus 166 is 78, so we would expect a heart rate of 78. So if we go from this dot over, notice we are at a heart rate of 78. All right, next one. Box and whisker plots. Now you're going to actually have to make a box and whisker plot. But just to help you, remember how the box and whisker plot and what the parts mean. This is the minimum. This is the maximum. This is Q2, this is Q1, and this is Q3. So if we look here, to find out which one this is, we just look at the different dots and we see which one matches. Well, if you notice, 41 is the lowest. That's the lowest in A. 41 isn't in B. 41 is in C twice. 41 isn't in D. So we know it's either B or A or C. What's the biggest number? The biggest number is 98. 99 is in A, so it can't be A. It must be C. Where is 98 there? I don't see 98. There it is. 98. So C is the correct answer. But let's make a box and whisker plot of one of these sets of data. Okay, here we go. Let's all 25 of them there. So our lowest is 40, so that's this end of the whisker. Our highest is 99, that's this end of the whisker. Then our middle one, since there's 25, our middle one will be the 13th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is Q2. Now, that means there's 12 down here. Half of 12 is 6, so it's between the 6th and the 7th. 1, 2, 3, 4, 5, 6, 7. Halfway between these two is Q2, so that's 46. And then the same thing up here, 12 of them here, so 1, 2, 3, 4, 5, 6. Halfway between these two is Q3, that's 87 and a half. So the middle of our box is 62. If this is 40, this is 100. 40 to 100 is 60, so this will be 70. 70, and halfway between these two would be 65. And halfway between these two will be 85. So now our box starts at 46, because that's Q2. So our whisker is at 40. It goes over to 46. The middle of our box is 62. And the upper end of our box is 87. So this is how our box is going to look. 62, 87, and then our whisker goes out here to 99. That's how you do a box and whisker plot. Next. Okay, these questions about standard deviation, it's helpful if you have your normal curve. A company installs 5,000 light bulbs with an average lifespan of 500 hours and a standard deviation of 100 hours. So if that's 500, this will be 400, and this will be 600. Find the approximate number of bulbs that are expected to last less than 500 hours. Okay, so we want all of the light bulbs here that are less than 500 hours. Well, what proportion of our graph is that? This is half of our graph, 50%. What's 50% of 5,000? 2,500. Next one. Calculate the GPA. Okay. So you take 2 2/3 times 4 is 4 4/3, or 5 1/3. 4 times 5 is 20. No, 2 2/3 times 4 is 8 8/3. 8 8/3 is 10 2/3. This one's easy because it's 0. This one is 3 times 1 is 3. Add those up, you get 33 2/3. Add up the credits is 15. Oops. Is 15. 33 2/3 divided by 15. 33 2/3 divided by 15 is 2.24. All right, next one. A class has an exam average score of 76.1. Standard deviation is 5.6. How many standard deviations from the mean? So we're looking for the z-score, which is our score minus the average divided by the standard deviation. And in this case, it's 62.1 minus 76.1 divided by 5.6. So on our calculator, fraction 62 2.1, oops, 0.1 minus 76.1 over 5.6 gives us negative 2.5. Now, we know it's negative because our score is less than average. What does that mean? Well, if you look at a normal distribution here, here's a normal distribution where the average is 76.1 and a standard deviation is 5.6. 5.6 less than 76 is about 70.5. We are down here. Our score is way down here at, way down here at 62.1. So we are 2.5 standard deviations below average. In other words, our percentile is not very high because there's not very many people who had a worse score than us. Let's look at this next one. We're supposed to find the how this genetics works out here. Well, the first parent has a recessive gene of 0.45. So we make this one 0.55 because these two numbers have to be all of the amount. So this is 0.55 and this is 0.45. That's the probability of the recessive gene. Multiply 0.45 times 0.45 and you get 0.2025. Then if you take 0.45 times 0.55, you get 0.2475. So these two are 0.2475 here and 0.2475 here, because this one is lowercase g, lowercase g. This is uppercase G, lowercase g. Uppercase G, lowercase g. And then our last one is 0.55 squared. And we get 0.3025. All four of these added together is going to be 1. Next one. Calculate the 40th percentile. You guys are having a real hard time with percentile, and I'm not sure why. I gotta make sure we got this right here. All right. So on this table, these numbers are all arranged in order already. So we want 40 out of 100 because that's where the percentile comes in. We have 16 different numbers. If we cross multiply and divide, 40 times 16 divided by 100, we get 32 over 5, which is 6.456. The next one is 52.8. So since we want the 6.4th one, this is the 6th, this is the 7th, we have to go with the higher one of those two. Next. Where are we? Number 9. Nine people are eligible for selection to the Hall of Fame, but only 5 will be selected. In how many different ways can the selection be made? Since there are 9 people, and this is like a committee, we have 9, choose 5, 9, choose is my NCR key, choose 5, and we get 126. All right, next one. 10 fishermen had 3 different rods, a fisherman Why did I say 10? A fisherman has 3 different rods, 10 different reels, and 4 different spools. How many different ways can he prepare to catch fish? Multiply those together, and you get 120. Next one. A bag contains 6 red marbles, 3 blue marbles, and 5 green marbles. Give the decimal probability for choosing a green. Remember, probability is favorable over total. So we want green, which is 5, out of 6 and 3, and 5 makes 14. 5 out of 14. 5 divided by 14 is 3 point, what are we supposed to do? 3 decimal places? 3.57. Next one. Consider the following table of 195 students to tell the probability of choosing a student in agriculture or childcare. So add these two together, you get 46. Oh, I'm sorry. Sorry about that. I gotta erase this. Here we go. It's 22 plus 29 plus 24 plus 26 over 195. 22 plus 29 plus 24 plus 26 over 195 is point, how many decimal places? 3 decimal places, so 0.518. Probability is 0.518. Next one. Consider the following table of 181 customers and tell the probability if the person is a, if the person is a Vonage customer, the probability that they chose a smartphone. So we just have, our total is not all of the people, but just the 23 and the 16 who are Vonage customers, and then their probability of choosing a smartphone. So our probability is fraction 23 over 23 plus 16 is 23 out of 39. Oh, I got to get that as a decimal. Is 0.590. Next one. A classroom has 18 women and 16 men. What is the probability of selecting 2 women in a row? So it's 18 out of 34 plus 17 out of 33. Fraction 18 out of 34 plus 17, out of 33 is, oh, we made a mistake. It's not plus, it's times. You notice how I knew I made a mistake? Because I got a number bigger than 1. So that's quality control. 18 out of 34 times 17 out of 33 is 0.273. Okay. Use a chart to find the probability of selecting a student who has failed at least one course. So they failed 1, 2, 3, or 4 courses. At least one, it says. The easiest way to do this is to take the probability that they didn't fail a course, 218, out of the total number of students. So on our calculator, we would say the fraction is 218 over 218 plus 1482 plus 161 plus 113 plus 74 is 109 out of, what was that again? 109 out of 1024. So our answer is 1024 minus 109, because all of the rest of the people did fail. So it's 915 out of 1024. Let's write that as a decimal. 915, 15 fraction 1024 is 0.894. Next one. A raffle for a $332 prize has tickets that cost $3 each. There were 227 tickets sold. What is the expected value of the ticket? Okay, so the payment, so expected value is the payment 227 times $3. Okay, but that's how much people are going to lose. There's one person that's going to win, but he's not going to win the whole $332. Well, I guess we'll do it that way, yeah. The total number of people losing is, everybody's going to lose $3. This person is going to also gain 332. So if we take on our calculator, 1 times 332 subtract 227 times 3, we get negative $49 negative divided by the 227 people. The average person is going to lose $1.53. I think it's $1.53, $1.54. So in other words, whoever's putting on the raffle is going to gain $1.54 per person. Next ones. In a survey of voters, 8 potential voters were asked if they approved of a referendum to fund 8. What's the probability that 5 or fewer voters will approve of the referendum? So on your assignment, on your test, I'm going to give you this chart that you see here. In order to solve this problem, let's make this chart small enough so that we can show the chart and the test both. Oops. And the test question both. Okay. So here's the chart, and it goes, and it goes with this question right here. All right. So 8 potential voters, we want out of those 8, 5 or fewer. So 5, 4, 3, 2, 1, and 0. All right, round to 4 decimal places. Well, this first number is 0.00000 256. So that one you don't even need to add because we're only going to 4 decimal places. 0.00089192. So that we don't have to worry about adding that one. The only 4 we need to add are those there to get 3 decimal places. So we're going to add those 0.00114688 plus 0.00917504 plus 0.0458752 plus 0.14680064 gives us about 20.2030 is the total probability. Next one. Oops, let's get our calculator out of the way. Next one. Consider the following table of 166. Give the odds in favor, odds in favor of choosing a student in the ag program. So we've got ag students versus non-ag students. So our answer is going to be 19 plus 16 to 38 plus 59 plus 15 plus 19. Odds in favor. Remember, favorable to unfavorable is what we want. So 19 and 16 is 35. And 38 and 59 and 15 and 19 is 131. In a horse race, the odds against the horse winning are 5 to 4. What's the probability? So the favorable is at the end, because against is unfavorable to favorable. So we have favorable over total, 9, which is 0.444. Last one. The library kept track of the number of students on the computer for each hour. They recorded these results. Make a stem and leaf plot. Okay, 6, 3, 3, 6, 1, 5, 4, 9, 9, 5, 2, 3, 3, 2. There's our stem and leaf plot. That's the test. So you can see how it goes.